This revision deals with metal frames of a building or structure in accordance with 250.121b. And basically, this section is saying, in the purpose of change, it's basically saying in this revision to clarify that the structural metal frame of a building or structure restricted use shall not be used as an equipment grounding conductor. Now, this used to be in the last sentence of 250.136b, but they wanted to relocate it here because it made better sense to put it over here dealing with a metal frame of a building or structure. Now, notice everything that we see here, the metal water pipe and all, the metal water pipe is our main electrode. You see in the call out metal water piping here, notice it's 250.50 and 250.52A1. So 10 feet or more is in the earth, so it is your qualification to be the main grounding electrode system. And then if you look at the metal enclosure, and also, the call out says also, for metal enclosures as an effective ground fault path, see 250.109. And that basically, you know, metal enclosure has to be bonded into the grounded bar and earth grounded to reduce the threat of electrical shock to a person. Now, first of all, I'd like to kind of get the call out to the left. It's pointing an arrow to the structural building steel, and it talks about it shall be effectively grounded. Now, you know, if it's not already an electrode, 10 feet or more of it in the earth, or it's connected into one of the electrode systems, then this 250.104c says it's not an electrode because 10 feet or more of it is not in the earth, say, then you have to bond it in. So it is. It could be bonded into the grounded bar and the panel board. It could be grounded to the grounding electrode to the water pipe. It could be connected to the water pipe, or it could be connected to the concrete encased electrode. And then notice that in 250.52A3, dealing with the concrete encased electrode, you look at 250.52A2, the building still is not an electrode, so it falls in this 250.104C. It has to be bonded in, so it is an effectively bonded into the grounding electrode system as required above, where it says it's not a grounding electrode conductor, as 250.52A2 requires it to be if it is an electrode. The exposed metal is the frame of the building, 250.104C, where separately derived systems could be grounded to that metal frame, sending an unbalanced current flowing over it in some cases. And so we have to bond and ground to kind of protect that. Then notice in one of the call-outs there, the grounding electrode conductor is properly sized, as 250.104C5 calls for, if it's not an electrode. Metal water piping, then we've already discussed that. So next, I'd like to kind of look at the circled green number 1 rule, and it says bonded service grounded conductor. So 250.104C2, yeah, it's earth grounded. It's connected to the metal enclosure. All equipment and grounds connect to it, so that we satisfy the code there. Item 2, the steel is bonded to the grounding electrode. That's okay, according to 250.104C4. And when you look at number 3, we could take the steel and bond it to the concrete encased electrode, CEE, 250.52A3. And now I would like to go over the notes. Note 1, to the right, with an arrow pointed to the structural steel, says structural metal of a building is not to be used as an equipment grounding conductor per 250.122A and B, 300.3b, and 250.134b. In other words, kind of review those 3 sections, and it makes a lot better sense is what's taking place here. And remember that the structural steel used as an equipment ground is no longer in 250, .136b. Note 2, 4-aught THWN copper conductors require a number 2 for table 250.66. That'd be number 2 run over there, see. Now, the note number 3, kind of finalizing this, an equipment ground should not be used as a grounding electrode conductor per 250.121a. Why is that? Because if I grounded and used the grounding electrode as an equipment ground, if I grounded here and you run back here to the transformer, you have 5 ohms here, 5 ohms here at the transformer, and 5 ohms at the service. You add them together, that's 10 ohms. 10 ohms into 120 volts to ground is only 12 amps. You're never going to clear an overcurrent device through the earth, see, because the resistance is too high. If it was 277, 480, then 10 ohms into 277, rounded up, you only got 28 amps flowing through the earth because of the high resistance of the earth. So that's why this was put in again to remind electricians, don't use the earth as an equipment ground. It has to be a grounded conductor on the supply side, and it has to be an equipment ground on the load side, see, based upon the protected device that's ahead of the conductors. From the transformer, you don't have an overcurrent device ahead of those conductors, so table 250.102C1 would size the grounded conductor there that's used as a equipment grounding means. It's basically, it's used as a neutral, and it could best be used as a grounded conductor. So it could be used as a bonding jumper. So it really serves about 3 conductors, there. It can serve as a function for 3 conductors there. So keep that in mind, and then you can understand why this revision took place, and they relocated 250.96b, last sentence, over to 250.121b. So keep that in mind, and then in the earth, look at 250.94 and 250.96, and you can't use the earth as an equipment grounding means. And I think that wraps that up real good for you if you want to look those sections up.